The first step of the LCA is to quantify. So you would need to quantify environmental and financial performance, how to do that. And there are different things and topics you would need to think of. So first of all, international standards will help us to understand how to quantify it. Secondly, we need to understand the scope of assessment, so how much of the product or a building you would like to assess. You need to define this system boundary. You need to define functional unit, service life. You need to look at database, lifecycle inventory, and impact categories. So we'll cover all of this shortly in the next couple of slides. So the most important standard that explains how to calculate environmental performance of the whole building is EN 15978. And eTool didn't invent here anything new. We simply simplified this standard and integrated the requirements into the software so that it's compliant to what is needed to calculate the whole of building LCAs. We also are compliant to different rating schemes like LEED, BREEAM, Living Building Challenge, One Planet Living, UDIA, DGNB, Green Star, and ISCA. So ISCA is infrastructure, Green Star is buildings. We're speaking here about Green Star application. Sorry for that. So now, a very important slide, and I'd like to pay attention here. Probably you know it from the university, and I have noticed there are a couple of students that participate in this training. So LCA includes different modules. Basically, this is scope of assessment. And if you see the black line describes the building life cycle system boundary. It includes modules A, B, and C. Module A, 1 to 3 is basically the origin of the product, where materials come from, how they are transported to the site where they will be manufactured. So it's, for example, coal and mines. Construction stage, A4 to A5. So it's basically the installation process to create the building. So all the excavators, people, all the materials that are used, how they're transported to the construction site, how long it takes, normally a couple of years. So this is the stage of assessment. Another stage is use. This is basically our service life. So for example, a building should last 40, 50 years or longer. GBCA recommends to set 60 years as a default life of the building. However, as we all know, the bitter reality is that often it just depends on the redevelopment plans. And it can be just 15 or even 20 years. So the use phase includes also maintenance, repair, replacement. So it's a very important point when we try to plan in advance long term and think of also what would happen later on during the use of this building. Some materials have only maybe 10 or 15 years service life. Some others would have a longer life. So those with shorter life would need to be replaced or repaired. In this phase, we also include operational energy and operational water, and that's another thing to remember. B6 module, very important. This is operational energy, and this is basically where most of environmental impacts come from. And end of life impact, so basically the building served its life needs to be deconstructed, and so we need to think about waste, disposal, and so on. So it's quite significant too what happens here. And the module D is also something we can include, which means everything that goes beyond the building boundary. So reuse, recyclability of material, exported energy. For example, if you've installed an energy system that produces more energy than than the building needs and consumes, then you might be able to export something through the grid. So functional unit is another interesting thing to think of. What do you think is more environmentally friendly? So the left coffee machine, the right coffee machine, how would you measure it? So we need to think about the function of the product or the unit. In this case, what's the function? To produce coffee. So it can be a cup of coffee. So this is our functional unit. So if you have a coffee shop, then probably the right option is better for environment because looks more robust, uses probably some steel, some recyclable materials, would not need to be repaired so many times. There will be some replaceable parts. It would last longer. The distribution of energy and water would be better through the whole system. So if you have a high turnover, then there's definitely a better solution in terms of environment and probably cost as well. Whereas the left coffee machine have some plastic, but this would probably be a better option for you if you don't have so many cups of coffee and if it's just a house solution for your private use. So all these things we need to consider, and that's how we're going to measure environmental performance. It's going to be unit, functional unit, kilograms of carbon equivalent per cup of coffee. So in the built form, it's very similar. We speak about different buildings and what their function is. In terms of residential buildings, this will be a number of occupants. So we will measure impact per occupant per year. For example, a benchmark in Australia is 4 tons of carbon equivalent per occupant per year. Commercial buildings will look at gross floor areas, or even better, net lettable areas, so really this usable area for commercial use. Hotels, beds, stadiums, number of seats. So quite easy, just think about the function of the building. Now let's look at the inventory. So in the software, there is a huge inventory that we use with already pre-assessed materials. So basically, any material has also kind of a life cycle, and this is an example of steel. Steel is a very nice material that can be recycled, and that's why it's quite environmentally friendly. So LCA for materials is called EPD, or Environmentally Product Declarations. So this is basically this label that you can see on the product that shows you all the impacts, environmental impacts on water, air, soil that this product has. And there are different impacts that can be assessed. So on the left bottom, you can see parameters, global warming potential, and so on. I'll go through this shortly. You can also see the stages that I mentioned before, A, 1, 2, 3, B, C, D. And as you can see, most of it is gray, so it cannot be really assessed by the manufacturer of this product or of the material, which is steel in this case, because they simply have no influence on how the product will be used in the future. So they can only influence the origin and or how it's being produced, and maybe some recyclability potential that they could assess. So if we look at the first parameter or impact, global warming potential, you would see only modules A1, 2, 3, and D. So A1 means the raw material supply, so the extraction of the material from nature. So this process is quite carbon intense, as you can see. We almost 2,500 kilograms of carbon equivalent is being produced here. Into other phases a bit less, and interestingly, you would see a negative impact, which is basically the positive impact. So minus 800 means that this material can be recycled or reused somehow at the end of life. So that's why if you use materials that are recyclable, then you could reduce your total impact because this will be a sum of all of them through the life stages. So please remember these 7 impact categories that are shown in this example, because these 7 will need to be assessed for Green Star submission. So we will need to assess global warming potential or carbon equivalent. We need to assess stratospheric ozone depletion. So as you know, there is an ozone hole over Antarctica. We need to assess photochemical ozone creation, so the smog. Acidification of land and water caused by acid rains. Eutrophication, so this is excessive growth of nutrients in water bodies caused by use of fertilizers in agriculture, for example. Quite a nasty picture, okay. And finally, mineral depletion and fossil fuel depletion. So these 7 are most important and probably the worst impacts on the environment, and that's why they need to be assessed for the LCA. The second step is to compare. So what are we going to compare now? We need to think about 2 different designs, right? So we're proposing a design for Green Star submission. This is our proposed design, and there will be a reference case, which is a benchmark, right? Something we will compare against. So we normally compare to something that is just below 4 Green Star buildings in the same location with same parameters. So when you would use the software, you would need to conduct a benchmark model and then a proposed model to compare to each other. Finally, how it all happens. So lifecycle assessment is described in the document of GBCA, and it's called comparative lifecycle assessment. So this, sorry, I'm not sure. Yeah, that's all good. So this comparative assessment would give you 6 points if you would compare and show that your proposed design is 130% better than business as usual or the benchmark. So basically, you would need to somehow calculate impact reduction that you generate through proposed design. So if you would additionally achieve even more reduction, for example, 20% more, then you could get innovation credit points. 40% more to this would give you 2 points additionally. To improve, that's our favorite step, and that's what all life cycle design is about. So we need to improve our proposed design to get there, to get these improvements, right? To show that we are better than the benchmark. So how we can do this? We can, of course, improve design life. We can improve layouts, and that's why it's or the occupancy or net lettable area, optimize areas, car parks, reduce common areas, and so on. So of course this step is really only possible to do on a concept phase when you just play with different ideas and you're still quite flexible with decisions. It's not possible to do it later on when design progressed. We can also improve something about energy models, so lighting, HVAC, very important. Maybe install some sensors, battery management system, of course, use of renewable energy, solar, thermal electricity, and certainly materials. So we would try to replace one material through another and use some materials that are more durable, have low maintenance, and have lower end-of-life impacts. Finally, this improvement step is also required in the document in the version 1.2 of the LCA credit for Green Star. and you will find that things changed compared to another version, and you would need to show some additional improvements like material selection, construction process improvement, LCA design review. I will go through all these points just in the next chapter. Let's look a bit closer at Green Star and how we can apply LCA credits. So as you know, Green Star has all these different credits, and if we want to use LCA, we can use it for materials credit. And it's called Performance Pathway Comparative Assessment. And you could get 7 points for design build projects and 19 points for interiors. However, actually, as you already have a feeling that LCA covers only other parts of the credit. So we cannot deliver them, but we can give some input for those credits. Very important that with using the LCA, you can get some innovation credits, as I described before, 2 additional points available. So in total, 7 plus 2 will be 9 points. Design and as built. So we have 2 different versions of Green Star documents. The first credit was published mid last year, or even before, so mid of 2017, and everything after is version 1.2. So with the previous credit 1.1, we had a different assessment. So we had comparative assessment, so LCA, that would give you 6 points. And then if you would report on additional life cycle impacts, like a report on more than those 7 impacts I mentioned before, acidification, carbon, ozone depletion, and so on, then you would get 1 more point. So in total, you had 7 points. Now, the spread looks a bit different. It's not very accurate, this graph. Basically, you still can get 6 points with life cycle assessment, and on top of that, those are the points. But it became a bit difficult because of the double counting. Basically, what happened, so the LCA life cycle or comparative assessment was cut to 3 points if major reduction would come from the module B6, right? So the operational energy, and it really makes sense. There was a problem of double counting. So some benefits of operational energy that you could show, then you could get greenhouse gas emissions credit. So you could get those for this credit and for materials credit too. That's why it was double counting. And the comparative assessment, or LCA, was capped to 3 points if the most of it comes from operational energy, which means you still can reach other points from other ways or from other modules. You would just need to report on this. I'll show you later how it goes. The new about this credit 1.2 is that there are other categories where you can still get 4 points, and the sum of it will be 7. So just as in previous credit, it is additional life cycle impact report and 3 more different points. If you would show that you improved some material, that you improved the construction process, and finally LCA design review means that if you can prove that you started using LCA in the concept phase to inform design team and improve decisions. So this design review means kind of a preliminary assessment, very simple and generic of the concept. And then the full assessment will need to be done later on, which will be that part. All right, let's go further. In interiors, same thing, just with another number of credits that can be granted. So 19 instead of 7. I won't go here into details. LCAs can be done now even easier, that's in our experience. Also because we automated reports. So when you use the software eToolLCD, you can just concentrate on modeling and choose from available reports, and then the software will generate the report that can go just one by one to for Green Star submission. So no paperwork. You don't need to describe and create graphs and copy paste things from the software. This is an example of the report and just an extract. How we show different modules, for example. So here are these 7 impact categories we need to report on. And so a model, and then we can show different modules and where most savings are coming from, and then report how many savings coming from the module B6. Another view is on the calculation. So you will have the full transparency of where you are at. So again, on the left side, you've got these impact categories, and if you will count them, then you would find more than 7. So you would find, for example, particular matter or land use or water footprint or human toxicity, cancer, and so on. And in the software, we've got 20 plus impact categories you can choose from, and if you would like to report on some specific ones. So basically, 1 point for additional impacts reporting is always granted. It's just there always. Finally, you would need to calculate how much better your design is compared to the base case or the proposed design. And this works this way. So you would sum up the percentages of savings for each impact category. And if you are 130% better or savings achieved are 130%, then you would get 6 points, right? Then if you are 150% better, then you would get 1 innovation point. So you could claim using the same LCA basically. And 40% better is 2 innovation points. So you could achieve 9 points with 1 single LCA. As to the second credit, 1.2. I will go a bit more into detail now for these new things that need to be considered. So material selection improvements, you will get 1 point for this one. So simply you need to show that you have an idea how you're trying to use a material that would bring some savings and improve the design. So you can, for example, replace, tin bath and or like compare something a material that has an EPD, so environmental product declaration, and where you think maybe it's makes sense to use this material more in the whole building, and you can calculate the percentage of savings using this using the software. Same thing with construction process improvement, and this is where it goes into the modules B4, B5, A4, A5. The construction process, so some excavators, maybe you want to use renewable power during construction and show what it would do to the whole environmental performance, or you try to use less excavators or different equipment, local suppliers, for example, locally sourced equipment, because everything will need to be delivered to the site. So all this transport will also be considered. So just as a hint of those little things that you could do, and it's more up to you, it's more about your design creativity and what you think you could implement to improve design. And as I said, the last bit is the LCA design review, which is also means that you need early engagement of LCA, preferably at the concept design phase, and this needs to be documented. So we can also help to document this design review to get one more point. Finally, the last step is to certify. So you create the LCA model, you have compared them, you showed how you're going to improve the design, and then it goes into submission. Someone, a third party, needs to certify it. And our company also can provide this service. It's also in our terms and conditions. If you use our software for commercial gain, then we would expect you to certify it with us. And also it makes sense that we look over the model, and help you to get there, help you to make sure it's compliant. We would check some geographical and technical relevancy and validity of claims. There is also like the whole of compliance criteria you would need to think of, different standards, reference buildings, details and requirements, some documentation that would need to be submitted and will need to go into the report. And also, for example, LCA practitioner competencies statement. This is something interesting. This is a bit of a chicken and egg problem. So GBCA requires that you can submit an LCA for Green Star only, or a project only if you are a competent LCA practitioner, which means that you need to prove that you have conducted already 5 LCAs before. Yes, so, but this is not a problem. It's that you can simply count with us. So we could co-author your LCA if you want to use the software in-house. So we will just provide some consultancy hours and look over your model and help you to get this one of 5 LCAs until you can be called a competent LCA practitioner. So it's not really a problem.